Hey there folks, welcome to Learn to Code Seoul. So I forgot to record the very first class, so I'm doing this kind of backfill. So don't mind if things seem unusual, either now or in the future. But today we're going to cover downloading and installing Java, along with writing your first tiny little program and making sure that everything runs properly. We need this as a starting point so that we can go forth and create more advanced applications as we go on through the class. So you'll want to open up your browser of choice. I happen to have Chrome. If you use Internet Explorer, Firefox, whatever, that's up to you. But you want to just search you want to search JDK download. And you should see Java SE Development Kit 8. So JDK is short for Java Development Kit. It is all the stuff necessary for you to develop Java applications. 8 is just the version we happen to be using now. If someone in the far future is watching this, you may want to look for 9 or 10. I generally recommend whatever the latest version is, because Oracle, the creators of Java, there's also an open JDK, but for purposes of this, we'll be using the Oracle version. Oracle will make the general release version usually the more stable version. There will be a more advanced version, but it might not be quite as stable yet. So if you just search for the latest JDK version, you should be fine. And then you'll appear at a page like this. Let me actually make this bigger so you guys can see it. All right, and you'll see Java Development Kit. You'll notice that this actually has a higher number than this one. I believe. Make sure I'm not a liar. I believe that's because this is considered the more stable version. Yeah, I haven't done this in a little bit. So yeah, I believe that's because this is the more stable version. So we'll just roll with this. You need to make sure to check that you accept the license agreement, and then you want to select which version, which operating system you're using. If you're on OS X, that's easy. You just pick this one. Whoop! If I could highlight properly, just pick this one. If you are on Windows, chances are you have a 64-bit system. If you're not sure, that's probably what you have, so you want to download this one. For purposes of speed in this video, I've already downloaded this. And you'll see this JDK file right here. You'll want to open this. And on Java, what you'll download is a DMG file. If you open that, you'll see a package. It'll look like a little box. If you double-click that, and you just run through the installer like we're going to do here on Windows, it should be pretty much the same. So here we go. You'll see Welcome to the Installation Wizard for Java Development Kit, and you pretty much just keep hitting Next. Mine will probably complain because I already have it installed. Actually, I'm going to go ahead and just cancel. For those of you running through this for the first time, you just want to keep hitting Next. So once you've got that going, if you're on Mac, I'm pretty sure you're done. You're ready. On Windows, we have to do a little bit more work. Things might look a little bit different for you, depending on what language your version of Windows is in or what version of Windows you're using. For example, if you're using Windows 8, some of the windows will look slightly different. But bear with me here. It should be similar enough that you should be able to figure it out. So you want to hit your Windows key, bring up your Start menu, and you want to search for environment variables, right? And you want to edit the system environment variables. Okay, you should see a window like this, and you'll want this environment variables down at the bottom here. So you want to click that, and then a new window pops up because Windows does Windows, right? So we're actually going to put that aside for now, okay? Because we need to go look up more information. You want to open up your file browser. Again, this is only for Windows folks, so if you're on Mac, I'm asking that you just be patient. And if you're on Linux, you may know how to do this stuff already. So you want to open up your file system browser, and you want to navigate to your program files directory. It should be on your C drive, unless you have an unusual Windows installation. And you want to look for program files, Java, and you want to search for one that says JDK. So you want to go to Program Files Java, and then you should have at least one JDK. You might have a few JRE versions. JRE is the Java runtime environment. That allows you to run Java applications. The JDK, the Java Development Kit, allows you to create Java applications. So we're going to go ahead and open this up, okay? And then you'll see at the top here you should have a path. If you click it, like it'll look like this, but if you click it, you'll get some text here. You want to go ahead and copy that, okay? So back over in your environment variables, and you should see, in this case, I'm going to go ahead and delete this so I can show you how to do it. In this bottom area, these are your system variables, okay? So these, if you have multiple users on your computer, these are settings for all users. If you don't know what I mean by that, don't worry about it, you're okay. So click the New button. Okay, so you should see a new window that looks like this, and you'll want to call it Java_home, spelled just like that. This must appear exactly like this. And remember how we copied that path earlier? You want to just go ahead and paste that here. Bam. That's all you got to do. Then hit OK. Alright. And you'll see now in this list right here, you'll see Java Home. Okay? That's basically telling any of your Java applications where they should look to find all of the necessary files to do the Java things. Okay? Now, there's one more thing that we can do, that we should do. It just makes life generally easier. You'll see this path variable. You want to be very careful when you're doing this, otherwise you might make yourself very unhappy very quickly. So, what I want you guys to do is go back to your file system browser in that same folder, okay? But this time go to the bin folder, okay? Bin is generally short for binary or binaries. It's where the actual executable files, as you can see these exes, it's where the exes actually live, usually when you're making an application. So you want to copy this path up top here, just like we did before. And if you go back to your environment variables, you want to edit this path variable. And you should see yet another window come up. And for people using a version of Windows before Windows 10, it will look slightly different. You won't have this nice listing here. You'll have just basically a name and then a really long value string. When it comes doing it that way, well, let me just show you on Windows 10 and then I'll show you the new one. So you want to, on Windows 10, you want to hit New, okay? And then you just want to paste that path. You'll see I actually already have it right here, so I'm going to go ahead and undo that. But it should show up in your list like this if you're on Windows 10. If you're on a version of Windows before Windows 10, you'll see something that looks more like just a giant text blob. What you'll want to do is something like semicolon, and then you want to paste the path, and then that should be fine. Once you've done that, just whoop! I have messed up all of the things. What am I? Oh God. Okay. Okay, there we go. Then just hit OK, and then hit OK. Whoop! And then hit OK, and then hit OK. So now. What we just did was, first off, we told Java where it was installed. That's what we did by setting the Java home variable. And then that second part, the path, is where your system looks for executable files. Okay? And I'll show you what we mean by that in just a second. So if you open up command, if you just hit your start menu and start typing in command, like the word COMM, basically this up here. There we go. You should have a nice shiny command prompt that looks kind of like this, right? So from here, you want to test that everything's working. So you want to do Java space-version, just like how I have typed here. You hit enter, and if you see something that looks like this, you are good. You also want to do Java C-version, and then if you see this, you're also good. So what is this? What the hell are we doing here? Command line is just another way to interact with your computer, just like how we were browsing the file system earlier, right? You can navigate through folders, you can run files, all sorts of fancy things. So what we did here was we just tried to run the Java executable, and we said, hey Java, give me your version. And then this is the Java compiler. Okay, now this is where we get into a little bit of theory. Basically, when we start running our Java applications, this is how it's going to work. You write your Java code, okay? And then, once you've written your Java code, you run it through the Java compiler, okay? That's that Java C thing. That is the Java compiler. Java C, C compiler. Easy, right? And then that will create some bytecode files, okay? And I'll demonstrate this in greater detail shortly. Once those have been created, then we can actually run our Java program. The nice part is that Java runs inside what's called the Java virtual machine. What this does is it basically allows you to not worry about the operating system. So in more low-level languages like C and C++, you normally need to create different versions of your application for different platforms. So if I made a C++ application and I wanted to run it on Windows, right, I have to write it one way. If I wanted that same application on Mac, I would have to rewrite parts of it, right, because Windows and Mac, they don't behave the same. So the Java virtual machine creates a tiny little computer on your computer, and then your Java application runs inside of that. Okay, so it doesn't matter if the person who's running your program is running on Windows or Mac or Linux or whatever else. The Java virtual machine makes it so that it will run. You don't have to worry about cross-compiling for all sorts of different things, okay? So we're going to demonstrate using this after we write our first program. So open up your text editor of choice. I personally like to use Atom because it's super fancy. But Atom doesn't seem to work on this recording, so I'm going to go ahead and use Sublime Text, which is also an excellent program that I highly recommend. Alright, so now we're going to write our first Java program. For now, basically you just want to copy what I'm going to write. I'm going to explain it in greater detail later, but for now, just copy. And the rest will make more sense as the class goes on. So we want to define a new class. Let's call it Hello World. Okay. And we need our main method, public static void main string args. This probably seems like crazy voodoo magic. Don't worry about it yet. But this line, this is the important line. This will print to the screen, hello world. Okay? So once you've written this out, you want to go ahead and save your file. You can do Control S for a quick save. Right? And you can save it on your desktop or wherever, it doesn't really matter. But make sure that you call the file hello world.java. The first part of the name must match how it is in your class. Okay, so class hello world, your file name must match that, okay? So go ahead and hit save. And you'll notice that once you hit save, the colors of the text changes. This will be true of both Atom and Sublime. But if you're using something like Notepad, maybe not. But basically, the text editor is showing us that it recognizes it as a Java file, and the colors are just to kind of make it easier to see certain things. It'll make more sense, again, as time goes on. For this first class, I'm asking you to just kind of trust me. Okay? So once you've done this, we can go ahead and open up our command line again. Okay, so you can go back to your command line. Now, here's a thing. Ignore that. You may not be in the correct location on command line. When you see this, this is called your prompt. Okay, which is why in Windows it's called command prompt. You need to navigate to the correct folder. So wherever you saved it, in my case I saved it on my desktop, so I have to navigate to my desktop. So on the command line, you can use dir to show the contents of the current directory. So you'll see directory, and then you'll see like modified dates, the fact that this is directory, and then the names of the directories. So you want to find the correct directory. In my case, it's desktop, so I will do cd, which is change directory, okay? cd, and then desktop. The nice part too is that on command line it supports autocomplete. So if I just type desk, and since there's nothing else that has desk, I can just hit tab and it'll complete it for me. So now if I show the contents of the current directory, you'll see the hello world.java file that I created. Okay? For you Mac folks, navigating around the command line is slightly different. Your prompt is going to look different than mine because I am actually doing this on Windows. I just have made it kind of Mac-like. It's actually more Linux-like, but they're similar enough. When you see this tilde, that means your home directory. And you'll want to... navigation is somewhat similar, so you can use CD to change directory, right? But you can use ls to list the structure or list the contents of the current directory. So if I do ls, you can see here's all the stuff in that current folder. It's a bunch of junk. You can also do, if you want a prettier format, you can do ls space -l. Okay, maybe that's not prettier. You can use clear to clear the screen. But you can cd to change directories. So if I wanted to go to my desktop, right? Now that only works because desktop was in the current directory. So if I ls, you can see that desktop is one of the directories in my home folder. Okay, so then I can do cd desktop, and just like on Windows, you can use tab to autocomplete. Okay, and then I can use ls and see what's there. Additionally, I did this earlier and I totally didn't even think about it. If you use dot dot is actually to go up a folder. So if you found you went to the wrong folder, and this is true of both Windows and Mac, you can just do dot dot to go back up a folder. Now that we are in the correct directory, we're in the location where we saved our hello world.java. Now we can do javac. We can compile our file. So you do javac and then the name of your file. Okay, should look just like this. After that, you hit enter. And then it looks like nothing happens. Well, most often when things are going smoothly, it's silent. There's nothing to complain about, so it's going to keep its mouth shut. However, if you hit dir again, you'll see there's a new file. There's this class file. Remember in this diagram where we said you take your source files, you run them through the compiler, which is the step we just did, and then it creates these bytecode executable classes? That's this class file. Whoops. There we go. That is this class file right here. Okay? So this is the bytecode executable that we just made. So now that we've got our bytecode executable, we can go ahead and run our Java program. So we can do Java, and then you want to give it the name of your class, okay? So this is the class file, right? This is the source file, right? But we want to give it the name of the class, okay? In this case, our class is called Hello World, so we want to give it that name. And then it will look for any class files in the current directory that contain this class, okay? So you can just do Java Hello World, and then you'll see that it printed Hello World to the screen. All right, that was a lot of work, but we did it. Once you're at this point, you have successfully run your first Java program. Congratulations. It's only going to get a lot harder from here, but it'll be fun too. We're going to do all sorts of really cool stuff. Now, why Hello World? Well, it's actually a tradition. Most programmers, when they're setting up a new environment for the first time, they'll write a tiny little application, just like we did, called Hello World, to prove that the environment that they've set up is ready for them to start building applications. So if you've gotten to this part, congratulations again. You've upheld programmer tradition, and you're now ready to create more advanced applications. So now that we've got our first application running, let's go ahead and make some basic little things, okay? So we've got printing Hello World. Let's go ahead and cover variables, right? When you're making an application, you need to store data somehow, right? If a user inputs some text, or if a request is made, or if you're pulling some information out of a database or something, you need to keep track of the information that you've collected so that you can use it elsewhere in your application. So we do this with variables. You can think of variables just like, honestly, it's like variables from pre-algebra back in school, right? It's just a little thing with a name that you can store data inside, okay? However, in Java, we need to declare the type of variable. When I say type, I mean the type of data that we're storing inside the variable, right? Whether a number is very different from text is very different from the idea of a user, right? So we need to tell Java what type of data we're storing. In this case, we're going to start with something very simple. We're going to start with integers or whole numbers, numbers without fractions or decimals, okay? So we reference an integer using int, which is short for integer, okay? And then we want to give a name for our variable. This name can be anything. It's just a way to keep track of what data we're working with. In this case, we're just going to call it x. Okay? You could call it monkey. You could call it computer. It doesn't matter. It's just a name. You can give it any name that you want. So we're going to call it x, and then let's give it an initial value of 5. Okay? So you'll notice we have our data type, we have our variable name, and then we are setting it to some value. We are assigning it a value, and that value we're giving it is 5. Okay? Now, just like up here, how we printed out some text, we're going to do the same here. I want to show you how you can use variables. So if you do system out print line, and then you just give it x, okay? Whatever value is inside x will be substituted here. Okay? So given that, what do you expect it to print out? It should print out the number 5. So let's go ahead and demonstrate that. Go back to your command line, and since we've changed our source, we have to compile it again. So let's do java c hello world.java. Okay? Again, everything went fine, so nothing happens. If you see an error here, or if something is printed out, there's probably an error and you need to fix it. Just make sure that it matches what I have here. Go ahead and pause the video and make any changes necessary. Once you've got that going, you can do java hello world again. And then you'll see it prints out hello world because we still have that code there, and then it prints out the number 5. So again, that's just a demonstration of using a variable. Okay? Integers are not the only things we can store. We can store plenty more as well. We can store strings. String in programming lingo is the name for text. Okay? So what strings are actually collections of characters. Okay? So a character is something like a single letter, right? A string is a string of characters. Okay? So we can say learn to code. And if we go ahead and print that out, then we go back to our command line. Make sure to save. Always make sure to save. Okay? I've been using Control S, so that's why I haven't been seeing the little menu. And here's a kind of pro tip. Instead of typing java c every single time, if you just hit up, it'll go to the last command. You can also go down to go to previous commands. Okay, so I'm just going to hit up until I get to java c. Hit enter. Everything's cool. And then on Windows, you can hit down because on Windows, it keeps track of where in your history you are, so you can go up and down your history list. On Mac and on Linux, it always starts at the very end, so you'll pretty much always hit up. On Windows, you'll have to go back and forth between up and down. So I can hit Java Hello World and hit enter. And there you go. You see it printed Hello World, it printed the number 5, and then it printed the text in our new string, learn to code, right here. Okay? So again, to kind of recap, we created a string variable called text. We set its value to learn to code, and then we went ahead and printed that variable. Okay? Now you'll notice that we have semicolons at the end here. I've been kind of glossing over that. In Java, and in other languages like C and C++, semicolons are required. It's how Java knows that you have ended your statement, because you could technically write things like this. and that would still work. But don't do that. It's not very clear. You want your code to be clear. Okay? Now there's other data types. So we did integer. There's also float, which is a floating point number. Okay? Don't worry too much about what a float is. It's basically just another way to write a number, but it's a way to write very, very large numbers, okay? So if you put an F at the end of a number, it'll turn it into a floating point. But if we also do this, since we're saying, hey, it's a float, I believe that still works. Let's go ahead and test real quick, because I'm not entirely sure. Yeah, that works. So let's go ahead and system.out.println that. Floating point. Okay. And now if we compile it, whoops. If we compile it, and then if we run it, you'll see that it prints this 5.0, right? Floats have a floating point, right? The point being the decimal. Okay? There's something a little more common that you'll likely use called a double. Okay? Doubles are pretty much the go-to for storing decimal points. So I can say decimal equals 3.0, or I can just do 3 and it'll convert it to a 3.0. Either will work. Okay? If we do system.out.println decimal, it should print that out. Again, super basic stuff, but we got to cover it, right? And there you go. You see 3.0. The cool part too is that we can actually add things together, right? So we can do things like system.out.println text followed by floating point. Whoops. I should trust the autocomplete. So what this will do is it will print the text learn to code immediately followed by floating point, the number 5. Okay? So if we go ahead and run this, you'll see that, again, because it's a floating point, it does 5.0. You'll notice there's no space here. Java will do exactly what you tell it to do. We did not tell it to put a space, so it did not put a space. You can see that here. Okay? This addition right here, this plus symbol, is how you can add strings to each other. And it also works in math. We can do something like decimal equals 5 plus 10, and that would work just fine. But let's cover some other operators as well. So in Java, plus is plus, right? What's the name for... Let's just call it that. Minus is minus, right? So multiply is actually this star symbol here, this asterisk, okay? Divide, whoops, typing, is slash, okay? And then there's one more operator that is really, really useful. It's called modulo. And that gives you the remainder, okay? So if I had 7 and then modulo is percentage, 5, this would give me the remainder of 2. Let's go ahead and print that. Okay, so this will make our output kind of nice. It'll have the string modulo, and then it will append the value of the modulo variable. Okay, so let's go ahead and try that. There you go. Modulo is 2. Again, that's because the modulo operator gives you the remainder. So 7 divided by 5, there's 2 left over, so you get 2. Okay, so that is variables in a nutshell. Now that's how you store data, and that's how you do basic mathematical operators, right, with numbers. But what if I want to go ahead and maybe I want to do something a lot of times, right? Maybe I have some formula, right? So let's say that I had some formula like, let's actually make it a double. And let's say I had some formula like this. Right, something random like that, right? But these values might change, and I don't want to have to write this thing every single time. Now, this is a bad example. Okay, so sometimes so that covers basic variables and some basic mathematical operators. Now, what if I want to do a little bit more? For example, remember this text here, right? Maybe I want to say, and then I want to say some sort of name, right? But I need a way to kind of commonly, I don't want to have to write this whole thing every single time, right? I want a way to more easily do that. All right, there's a way to do this using something called functions. Functions allow you to basically take multiple actions of code and package them into a single name. So instead of writing things over and over again, instead of repeating yourself, functions allow you to just call the function name, and then it will do all the work inside of the function. It may sound a little confusing, but in a second it'll make a lot more sense. Okay, so let me go ahead and, so in Sublime and in Atom there's this feature called folding. So if you go to edit and you go to code folding, you can just go to fold. Whoops, okay, maybe not that much. Not that much! Oh god, how do I do this? I don't use Sublime that much. I use Atom more. Unfold. So Control Shift square brackets. Okay, so maybe I want to do, no, Control Shift. No. Control Shift. There we go. Okay, so we have this public static void main function, right, where we've been writing all of our stuff. But to define a new function, so this right here is actually a function definition. This is the function called main. Whenever we run this class on the command line, like we've been doing here, right? What's happening is Java's looking for this method called main, and it's just running that. So we want to define a new method, a new function. You'll find that I use the terms method and function interchangeably. They effectively mean the same thing. Okay, so you want to look for the curly brace that ends main. Okay, so you got your start curly brace and your end curly brace. And you want to add a few new lines. And you want to do public static, and let's just do void for now. And let's say print hello. Okay? And then you want to do your curly braces. Alright. And then let's just do system.out.println hello. Okay, whoops. Okay, so you should have something like this, and I'm going to go ahead and expand this again. There we go. Alright, so you'll see this is the end of the main function, and this is where our print hello function does. Now, I'm going to go ahead and get rid of this. Instead of writing system.out.println all the time, I can just do print hello. Alright, and what this does is any code that's in between these curly brackets gets executed here. Okay? So we could do even more. We can do like we could do something like this, right? We could take multiple actions in one line of code. Let's demonstrate. So Java C hello world.java, Java hello world, whoops. And you can see hello, hi, salutations. Again, that is run because this is inside the main function, and then we're calling this print hello function, and it's running these. Okay? So to be abundantly clear, when you see something like this, we are defining a new function. Okay, we're saying, hey, I want to create a function called print hello, it's going to do this. Okay? This is the function signature. Okay, some vocabulary here. This is the function signature, and this is the function body. This describes the function. This is what the function carries out. Okay? Function, method, same difference. When you call a method, it looks like this. It's the method name followed by parentheses. Okay? So again, as you saw, it prints to the screen, hello, hi, salutations. Okay? Now we can actually make this a little more interesting. Functions can be a little more dynamic than this. Let's define a new function. Public static void. Let's call it print hello name. Okay? Now we're going to do a little bit more than this. Why are there these parentheses? These parentheses actually allow you to give input to the function that allows you to change the function's behavior. Okay? So I can say you define an input, which is also called a parameter. Again, vocabulary, parameter. So you can define a parameter the same way that you would define a normal variable. So I'm going to do string, and I'm going to call it name. Okay? So this means that the print hello name method, that's what it's called, takes in one parameter. That parameter is called name, and its type is a string. If you try to give it any other value, Java will explode. It'll be like, hey, you can't do that. Don't do that. Okay? And what we can do is we can treat name just like any other variable. Okay? So this is our function definition. Here's the signature. Here's the body. Okay? And now we can do print hello name. And this time, inside the parentheses, we want to give a value for that parameter. It could be another variable. It could be anything. In this case, let's just do my name. Okay? Now, if we save this, what's going to happen is Java will look for a method with that name. It will find this. It will then see, okay, you've been given one parameter, and so name will be set to this value. And then that value will be used here. Okay? So, can you guess what will print to the screen? It should be hello, Beej. Let's demonstrate. There you go. Hello, Beej. No surprise, right? Now, you can go even farther with this. You don't necessarily have to give it a direct value. You can give it another variable. Okay? So, if we look up before, we had this text variable. We set it to learn to code. We can go ahead and pass in that text variable. So, whatever value is stored inside text will also now be the value in name when this function is called. Okay? Each time this function is called is unique. Name gets set to something different each time we call the function. Okay? So now, you should see a print hello Beej because we left that line there, and you should see hello learn to code because that's the value that was stored inside text. I should probably show you the command line. So again, compile, run, you'll see hello Beej, and you'll see hello learn to code. Now you're probably wondering, what the hell is all this stuff? Well, for these right now, don't worry about it. We'll cover it later, I promise. Okay? For now, we are going to address this though. When we see void, let me go ahead and actually fold these so that, whoa, hello! Fold these so that you don't need to see all this junk, okay? So, void right here, this location, in terms of the function signature, the method signature, this location is where you specify the type of data that the function outputs. Okay, now I want to be super distinct here. When we are printing to the screen, that is not output. Okay? there's no data being passed from one part of the program to the other. There's data being printed to the screen. That's a very explicit operation. Okay? When we say output, we're talking about data like it's being passed here with your assignment operator, right? With this guy right here. So we can actually run a function and return output. So let's go ahead and do that. Public static, okay, because I'm just asking you to roll with me for now. And then you need to define the type of data being output. So in this case, I'm going to define a function that outputs an integer. Okay, so I'm going to put int there. And I'm going to make this function called add. And I'm going to give it multiple parameters. A function can have as many parameters as you want, within reason. So I'm going to say it takes in an integer called a, and you can define a new integer with a new parameter with commas. And I'm going to give it an integer b. Okay? And then I'm going to return, this is a keyword, a plus b. So what will happen is, this method takes in one input, an integer, a second input, also an integer, then it adds those integers together, and then the return keyword will output whatever is after the keyword. Now, whatever this value is must match the type that is here, otherwise Java is going to complain. Okay? So now, back in our main, we can do int function sum. Actually, let's call it method sum, because that's less to type. Equals add. Let's do 3 and 4. Okay? Now, the reason we can do this is when you do a method call, and that method has an output type, it's very similar to a variable. Whatever this method outputs, in this case a plus b, whatever this value is, will be substituted here. So in this case, add is going to set a to 3, it's going to set b to 4, it's going to add 3 and 4 together, we're going to get 7. It's going to output that integer 7, and so therefore 7 is going to take the place here, and it'll be as if we were writing int method sum equals 7. Okay? So go ahead and save that, and then pop over to your command line, compile it. Oh, whoops. Sorry, before we do that, we should probably print to the screen. Whoops. We should probably print to the screen. Okay. So now let's go ahead and compile it. And run it. And there you go. Method sum is 7. Okay? So again, we defined a new method called add. It outputs an integer. It takes in 2 integers. We do whatever operations we need to, and then we return some other integer, because that's what we defined as the output. And then that gets substituted here. You can also write lines of code that don't actually run. This is useful if you want to kind of describe what your code is doing, which is, well, when you're writing as part of a team, really, really important. So you should get in the habit of commenting your code. So comments look like this. 2 slashes represent a single line. So this line will never run. Okay? Comments, single line comments, or lines of code, or lines that won't run, are preceded by double slashes. Okay? And you can put them anywhere in the line. You can even put them after an existing line. Right? So you can do something like that. You can also do multi-line comments using a slash star. Okay? And then a star slash to end it. So anything that's in here will not run. So this is a good way to basically just document your code inside your code. And I've made it terribly evident that I cannot type. So to recap, we went ahead and we installed Java and we configured it in a manner that allows us to run it on the command line, where you do your compilation step, which creates your class file. Okay? So again, you have your Java source, you run javac, which creates this class file. Okay? And then you run just Java to run your class, Okay. For Java C, you need to pass it the file name. For Java, you need to pass it the class name. Okay. And then in our code, we did a simple hello world program, right? And again, this is kind of boilerplate that you'll just want to copy every single time. And your class name must match your file name. Okay? So then we did a simple hello world. We covered defining variables and data types. We covered printing to the screen. We covered various data types like strings, floats, and doubles. We covered string concatenation, which is adding strings together. We covered the basic mathematical operators. And we covered the basics of functions. Basic functions that execute multiple statements, functions that take in a parameter in order to change their behavior, and functions that output certain types of data that can be used elsewhere. Sorry, right here. I know we went through a lot very quickly, but that's the pace we go at here. Fortunately, there are examples on the you search for the Beej basic programming examples. So GitHub, the Beej basic programming examples. If you just search for that on the internet, it should show up as the first result. And then for this group, you'll want to navigate to the Java folder. And here we cover all the basic things: hello world, variables, methods, and we also have the code that we write during the meetups in this Learn to Code Seoul examples directory. Okay? And here's a nice little snippet about Java, advantages, disadvantages, and here's a listing of the examples that you can go through, the various bits of code that you can cover in order. Okay? If you have any questions, comments, concerns, if you find a problem with the examples, you can go ahead and create an issue by clicking here. Again, you'll need a GitHub account, but you can just do new issue and be like, Beej, your stuff sucks, fix it. I'll be like, I'll fix it, okay. Or it might ask you to fix it. You can always fix it too. And we're also on Slack. So if you go to Learn to Code LA, because we share some infrastructure with the LA group right now, if you go to learntocodela.herokuapp.com, you'll see a little web page like this. If you toss your email in, actually, let's not do that. If you toss your email in, it will send you an invite, and then you can open up Slack. And it looks something like this. And once you get here, if you are part of the Learn to Code Seoul group, you will definitely want to mute the general channel because it's mostly LA people in that channel. To do that, you can go ahead and at the top, there's this little gear, channel settings. You can click that, and then you can say mute general, and that will mute general. Alternatively, if you want to mute the whole thing, which I don't recommend, you can hit this notifications button here, and it'll bring up, you can set no notifications for a limited span of time. You can say, hey, set a schedule to not disturb me if you want to not be disturbed during your nighttime hours. And then you'll want to join the Java KR channel. To do that, you'll want to click this channels text here on the left side, and you'll see things come up like this. Then you'll just want to search Java. You'll see Java KR. You want to hit that, and then it'll give you a preview, and then you want to click join. And then here we go. You can ask us questions on here, you can complain about things, or you can just chat. There's also a Korean channel if you either speak Korean or you live in Seoul. And you get there the same way that you get to Java KR. So yeah, feel free to join us on Slack and ask any questions. You can also leave comments on the video, and I will get to them in the shortest order that I can. Beyond that, thank you for joining us, and we look forward to having you code with us. Thanks. Bye-bye.